Let's solve a calculus problem involving derivatives. Given the function y equals x cubed minus 3x squared minus 2x plus 1, we need to find the values of x where the derivative equals plus or minus 1. Let's start by finding the derivative. Using the power rule and the sum rule, the derivative dy dx equals 3x squared minus 6x minus 2. Now we need to set this derivative equal to both plus 1 and minus 1, giving us two equations to solve. 3x squared minus 6x minus 2 equals 1, and 3x squared minus 6x minus 2 equals negative 1. Let's solve the first equation, where the derivative equals 1. Subtracting 1 from both sides gives us 3x squared minus 6x minus 3 equals 0. This is a quadratic equation that we can solve using the quadratic formula. For this equation, equals 3, b equals negative 6, and c equals negative 3. Plugging these into the quadratic formula, we get x equals negative of negative 6 plus or minus the square root of 36 plus 36, all over 6. Now let's solve the second equation, where the derivative equals negative 1. Adding 1 to both sides gives us 3x squared minus 6x minus 1 equals 0. Again, we'll use the quadratic formula. Plugging in these values, we get x equals negative of negative 6 plus or minus the square root of 36 plus 12, all over 6, which simplifies to 1 plus or minus 2 over the square root of 3. Let's visualize these solutions on a graph. Here's our original function in blue and its derivative in red. The points we found are where the derivative equals plus or minus 1, shown here as yellow dots. In conclusion, we found that the derivative equals 1 when x equals 1 plus or minus the square root of 2, and equals negative 1 when x equals 1 plus or minus 2 over the square root of 3. These points represent where the slope of our original function is exactly 1 or negative 1.